So here's a problem, and it's based on definite integrals. And it says that if the function f of x, if this function is equal to x cubed plus x, then the value of the sum of integrals, first from 1 to 2 of f of x dx, and second and twice the value of the integral from 1 to 5 of f inverse of 2x dx is. So how did we approach this problem? So this seems to be an easier part. You just need to like plug and get the result. This seems to be the more tougher part because this involves an inverse function, and finding the inverse of function, and especially a cubic function at that, is exactly not the kind of thing I would like to do in a good math problem. So instead, let's try using some substitutions, shall we? So since everything just looks complicated, everything right here just looks complicated, let's just say all of this is equal to something u. So let's just say is f of inverse of 2x is equal to u, and that means that 2x is equal to f of u. And once you differentiate both sides, so you get 2 times dx is equal to f dash u du, all right? So you have a 2 and you have a dx right there. So this can be written as from 1 to 5. Actually, not from 1 to 5. We haven't put in the limits yet, so no, not right now. Let me just blur it out a little bit for now, right? And let me use a different color, right? So the integral, now this thing right here, this is equal to u, and 2 of dx, 2 times dx is equal to f dash of u du, f dash of u du. What are the limits? So when x was equal to 1, u will be equal to f inverse of 2. Now f inverse of 2, notice that if you put in f of 1, this gives you 2. So f inverse of 2 is going to be equal to 1. Similarly, f inverse of 2 times 5, f inverse of 10. F inverse of 10, well, think about it. F of 2 is just equal to 10. And it very conveniently happens to be the limit that we have right there, right? So f inverse of 10 is equal to 2. So 2 to 1. This is the second integral. The 2 got absorbed inside. The first integral, well, that we didn't really do anything with that. So that's from 2 to 1 of f of x dx. This is a much easier problem to work with now. Why? Because we can club both the integrals together. So this is from 2 to 1, from 1 to 2 of f of t. Let's use another dummy variable. F of t plus t times f dash of t, all of this dt. And notice that this is nothing just the derivative of t times ft, product rule, right? So from 1 to 2 of d over dt of t times ft. And all of this is being multiplied by dt. This gets cancelled out. So you are left with t of dt from t times ft from 1 to 2. F of t is just this thing right here. Just put in t instead of x. So this is t times t cubed plus t from 1 to 2. And let me just use the space right there. And this is equal to t to the power 4 plus t squared from 1 to 2. So plug in 2 right there, so that gives you 16 plus 4, that's 20. Minus plug in 1 right there, so you get 1 plus 1, that's 2. This is equal to 18.